on creation first for the creation listeners, and then switch to English as a kind of small introduction. Dobro večer svima. Evo, Urania lectures and talks is going further. We had a little pause between New Year's even now, and I'm delighted to introduce you to Ivan Rupnik. And we are going to speak with him. Ivan Rupnik is a site friend. He's a tenured associate professor at Northeast University School of Architecture in Boston. Ivan has held academic positions at Syracuse University, Rhode Island, and so on, and he is Bachelor of Architecture from LSU and PhD from Harvard University. Maybe Ivan will tell you a little bit more about MOD X, his current practice and what he's doing now, and what he's launched last year, I think. Besides that, maybe it's important for the creation listeners to say about the two projects which is connected to Zagreb, to Croatia. This is the books. One is Project Zagreb, Transition as a Condition, Strategy and Practice, published in 2007 from Architekti. And one project which I was also involved in a way, a peripheral moment of natural agencies from 2010. I'm not going to go furthermore into introduction because I would like to start this as soon as possible.
Thanks. Thanks, Sasha. Can you hear me okay? There seems to be a bit of a...
Then I'm okay.
Much better now.
Yes.
Much better.
Yes.
Okay. Thanks, Sasha. So I don't know how well everyone heard the introduction, but I'm happy to be here. Thank you, Sasha, and Kino Rania for inviting me. Hvala svima. But the rest of the lecture and the discussion will be in English. We have an international audience, and I will be talking today about a kind of collaborative project, MOD X, and I'm going to start. I'll just jump into the slides and give a little bit of a background through that. So I'm going to share my screen. Let's see if that works. Do you see my screen now? No.
No, yeah.
Let me see. I'm not sure how to switch from one to the other.
Second. Now
Okay, so if I go, I see it's my screen. So if I go and maximize. Now, do you see my screen?
Yes, it's full.
Okay, great. So, so MOD X, we're going to be talking a little bit about what is MOD X and what do we do as a practice, and how do we look at the world, and particularly some topics. So, MOD X is a knowledge management enterprise bringing applied research, expertise, connections, and experience to both new and established players in the industrialized construction sector. But what industrialized construction is, and most of these words I will hopefully explain in a little bit. So MOD X is myself, Professor Ryan Smith, who's a director of the School of Architecture and Construction in Washington State University. And we've recently been joined by Tyler Schmetterer, who actually comes from industry, from the modular building industry, and who's also based between New York and Zurich. So we have a kind of a global presence. So Ryan and myself are both architects and professors, and we're involved primarily in academic research and publications. So we decided to shift or expand our work from academic research to industry through a consultancy practice. And so MOD X works with various companies and agencies, from education and networking to direct consulting and project, product, and policy development. Most of our clients and collaborators are usually on the outside of what we consider construction. So we've worked with municipalities, with different kinds of federal and national agencies, with owner-operators, with some construction companies, with NGOs, developers, building product companies, and as well as some big tech companies. Unfortunately, we can't name any of them because they have some serious NDAs or non-disclosure agreements. MOD X is also a network of experts. So we're trying to make sure that everyone in this new space that I'm going to be talking about today gets to know each other and gets to know their work. So this is something you can, if you visit modx.network, you can get to know really leading figures and up and coming figures in this new space of construction. This is just a screen grab of some of the discussions we've hosted just recently. I was using, again, the COVID-19 pandemic as a good excuse to spend a lot of time on Zoom and other platforms. But what I'm going to talk about a little bit today is, first of all, a lot of what our work has been is really just clarifying terminology in this new industry, which is in some ways in its infancy. And so what are things like industrialized construction, offsite construction, modular construction, maybe even a term that people might be more familiar with, or prefab, and how do those relate? And so we've tried to clarify those terms. So industrialized construction is kind of the broadest category. It's a form of construction where manufacturing industry processes have been applied. This includes moving some of the construction process into a factory, but it also includes bringing certain kinds of management practices, technologies from industry, from other industries. Industrialized construction really started with the Industrial Revolution. So big construction projects like the Eiffel Tower or the Panama Canal that you see on this image would not have been possible without the early modes of both management, design, as well as technologies that were developing at the same time within factories. And in fact, there was even a kind of a mutual feedback loop. But this kind of construction really moved into housing, actually around the eve of World War I. So this photograph is actually from a construction site in 1917 in Ohio, where a precast concrete panelized multifamily project was underway. In the United States, in the post-war period, industrialized construction was applied to wood construction, and so on-site. So projects like Levittown became quite efficient and economical through these principles. In Europe and also in the US and North America, these kinds of construction principles moved from one-dimensional to two-dimensional to even three-dimensional components, like the volumes you see here in Habitat 67 in Montreal. Precast concrete, two-dimensional precast concrete, let's say, dominated the sort of high point of post-war construction in the 50s and 60s. So offsite construction is a subset of industrialized construction. So industrialized construction is applying manufacturing principles on-site or off-site. Off-site construction is specifically fabricating or building in a factory, hopefully with the principles of manufacturing. So this is an image of probably one of the more sophisticated factories of housing in the world, Sekisui Heim in Tokyo, 1 million square feet or about 100,000 square meters, where a module leaves the factory every 3 minutes and 12 to 14 houses are produced every day. So modular construction is another subset. So modular construction, we use the term modular in architecture to mean all kinds of things. In the industrialized construction industry, modular construction is often synonymous with volumetric modular, which is three-dimensional volume subassemblies. But in MOD X, we also see modular, and McKinsey agrees with us, the global consultancy. Modular is also a way of thinking about production. So it's really modular is understanding design for manufacturing and assembly. Modules that are specifically designed for particular manufacturing and a particular assembly process, which are actually closed systems. And this is a diagram actually of the modular system, the product platform, something I'll talk about later, that powers the factory that we just saw. And prefab is still used. I would say prefab has become more of a colloquial term, a kind of lingua franca that's been co-opted actually by lifestyle magazines, which in a way is actually a good thing. So Dwell magazine, a very influential sort of lifestyle magazine and design magazine in the US, has popularized this concept in the single family space and dealt with some of the stigmas that modular, manufactured, montaged, prefabricated construction has in many countries, and sort of brought it a kind of cachet. So those terms, I'll use some of those terms and we can discuss what those are. Many of those terms are still in flux because of the renewed interest in this type of construction. So why is industrialized offsite modular construction such a hot topic now? And what has changed? Because it's been a topic many times in the last century, but has never really fully replaced on-site conventional construction. Well, in 2017, the McKinsey Global Institute published a very important report, which I recommend everyone read. We have a copy on our website, and obviously McKinsey does too. It's free. It really looks at the really tremendous drop in productivity of all construction, but particularly conventional construction, since 1968. So while every other industry has increased in productivity, including manufacturing, but also agriculture, retail, mining, using more or less the same principles, and we can discuss what those are, construction is really the only large sector that has dropped. And in fact, this was from an Economist article about the McKinsey report. The construction holds a dubious honor of having the lowest productivity gains of any industry. In the past 20 years, the global average has been inching up by 1% a year in most sectors, but not in construction. So Germany and Japan, sort of the leaders in high quality construction, have been basically stagnant over this period, which is actually the best that we've seen. France and Italy, for example, production has fallen by 1/6, and in the US, the productivity of construction has dropped by half since 1968. So quite a drop in productivity. And as the Economist reported from the McKinsey report, prices for building materials are not to blame. The burden over time of complying with regulation is only partly responsible, and we can talk more about that. More culpable are two broad structural trends. First, the industry has become less capital intensive, with workers replacing machinery, so reversal of the 19th and 20th century. And this is really a part of a kind of late capitalist volatility and demand for construction. So a boom and bust cycle. With each bust, we sort of seem to lose more, not just workers in the industry, but also mechanization, R&D, management. And the second big problem is that the industry, and this is true in the US and in Europe, for the most part, has failed to consolidate. So we have a lot of small players who have very thin, razor thin margins, and who can't invest not only in machinery, they can't invest in R&D, they can't even invest in full-time employees. And this is something that I know in Croatia, everyone thinks that labor problem is particular to Croatia, but actually it's a global problem. And so the positive news in the McKinsey report, the first McKinsey report, was that the solution seemed fairly simple: apply the same techniques that have worked for every other industry on the face of the earth, and use some of the same principles. So there's 7 areas that are identified where productivity can increase by 50 or 60%, which also includes prefabrication. And then for real transformation, 5 to 10 times productivity boost through applying a manufacturing style production system. And there's a little diagram of a house rolling out of a machine, which unfortunately just reinforces some of the biases that we at MOD X are trying to undermine a little bit. So buildings are not, believe it or not, and are not going to be popped out of machines anytime soon, but we are going to see applications of manufacturing principles more broadly. So just again, diagram for, particularly for the US, but certain kinds of drops are typical everywhere. And the lower productivity and a shortage of labor can explain the high cost of construction. So in 1968, let's say a certain consistent manpower and some mechanization, that's that little m, could produce a dwelling. If we take that drop in productivity, now it takes 4 times as many people, or a combination of people and time, to produce the same dwelling, which is a serious problem. So that shortage, that cost, has also been compounded by the fact that since 1968 in the US, and we can find similar problems across the globe, there has not been enough housing built, and there is now a huge housing shortage, which also compounds the cost of housing. So that has really changed the dynamic, at least in the United States and elsewhere. In Europe, the biggest change, which in the US hopefully will change soon too, is the very serious commitment to CO2 emissions, which are now becoming not part of just policy, but the economy. There's serious targets to decreasing those. And we know that between building operations and building materials and construction, the building sector has a real lion's share of CO2 emissions. And really the reason that, so offsite construction is seen as a way to both make more efficient, higher performing buildings, but also higher performing construction systems and higher performing supply chains. Also through offsite construction, there's an understanding that circular economy can be more easily applied. And those are all concepts that we can discuss maybe in the breakout. So while the demand has, so we understand a little bit about the terminology, and we understand what's changed. There's less people to produce more buildings, but there's also a challenge within, there is a offsite industrialized industry in the world. There are lots of companies, and yet in many places in Europe and in the US and elsewhere, there's the 3C challenge for industrialized construction, which is capacity, capability, and competency. So while some companies have capabilities, certain capabilities, some companies may have capacity, that combination of the two into a kind of competency is also a challenge. So in the US, about 5 years ago, modular construction, volumetric modular construction, had really only about 2% market share. Now, because of the US's size, that's still the largest volumetric modular industry in the world, but it's actually pretty low penetration. And that really had to do with also a fairly small number of players. And this is just a breakdown in the US of the distribution of both modular construction and another form of construction, manufactured homes, which I'll talk about in a little bit. So there's an uneven distribution, the Northeast having as much as 7% and the West Coast having as less than 1%. Manufactured housing, you might be familiar with, is really the mobile homes, trailer homes. So relocatable structures versus modular housing, which are components, three-dimensional components that can be assembled into really any kind of building that conventional construction can build. So Ryan Smith and myself, really MOD X grew out of a study and as a response to both the interest in modular construction in around 2016, 2017, but also the limitations to the 3Cs, competence, capability, and capacity. So we were asked by the Modular Building Institute, which is the main trade association in North America, actually has a membership in Europe as well, and in Latin America. So probably one of the few international bodies in this space, to look at the obstacles to growth, but also where were certain companies in certain countries or regions demonstrating kind of success. So Japan is on the cover. Some other countries I'll talk about are also doing some really impressive things. We walked away with that report with kind of a roadmap that focused on four kind of pillars: better data for the industry, a better understanding of competence, capacity, capability, a need for standards, and a need for partnerships between the industry to be able to not just grow the industry to 5% in 5 years, but to grow it 10% by 2025. So the market share actually has in the US, actually North America has increased, doubled. So US and Canada 4%, as much as 5% in the last 5 years. But I would say that much of that growth in the US and Canada is driven less by internal changes in the industry and more by the dire crisis in conventional construction, as well as the shortage in housing. So really external pressures on the industry, on the offsite industry, on the industrialized construction industry. While at the same time, the industry is having a hard time scaling up. So we've also looked at, which is why, sorry, this might be a little hard to read, but I can just say it. We've also studied the long-term development through national programs and private initiatives of sort of hot markets where offsite construction has been more successful. So in Japan, 15 to 20% of all housing is highly prefabricated, and most of that is in the single-family space. In middle-class housing, it's much higher. Probably 80 to 90% of middle-class housing in Japan is highly prefabricated, and has been for some time. And interesting enough, Japan started its offsite programs in the 1960s, but unlike many countries, just didn't give up. They kind of stayed with it and have seen real results that through just sticking with it. And so again, 5% of that is volumetric modular, and the other 15% are other offsite systems. So Sweden in Europe is quite unique in that a number of Northern European countries have a fairly high percentage of industrialized offsite construction in single family. So Finland, Norway, United Kingdom, Ireland have pretty high percentages in the single family space. Sweden is alone in having very high market penetration in multifamily structures. This is an image in the background of a mass timber project in Stockholm, 9-story buildings entirely built of mass timber. Mass timber is not a very large percentage, by the way. Even in Sweden, most of the construction is in wood, but is in light wood frame construction, which we can also discuss what that is and I'll show you an example of that. So these are just two diagrams. On the left, panelized construction, so light wood frame panelized construction, which is really, again, in Sweden and many Northern European countries, is really wood construction, light construction, and offsite construction are synonymous in the single family space, both in terms of structural panels as well as enhanced panels, so panels that have insulation, even sometimes cladding. Volumetric modular, again, and some mass timber in Sweden accounts for as much as 20% of the multifamily market, so three-dimensional components like that. Even zooming out, industrialized construction, and particularly wood-based industrialized construction, which is, I think, particularly important to understand in the European Union, where the sort of CO2 emissions targets will move probably construction into the wood and industrialized wood space. We have really three types of regions. So Canada and the US are unique in very high wood acceptance throughout the industry. As much as 90% of all construction in the USA is wood, and it's almost as high in Canada. That's totally exceptional compared to anywhere else in the world. There are parts of Europe where wood and industrialized wood construction, and the two are closely linked, are quite high. Northern Europe, some Baltic countries, as well as Germany and Austria, although in Germany and Austria, conventional block construction is still very dominant. And then you still have, and in Japan, where almost 80% of construction, residential construction is wood. In fact, 70% of it is heavy wood frame construction, a kind of an industrialized version of what many of you may be familiar with as sort of traditional heavy timber Japanese construction. And in New Zealand and Australia also have pretty high percentages of wood construction as well as industrialized construction. Another diagram within the European Union really shows the two leaders in terms of prefab, what is officially termed prefabricated wood buildings in the European Union by Prodcom and collected by the Commission. So Germany has the largest by value prefabricated wood buildings, although that industry is primarily export-based. Again, Sweden is unique in that it has developed through some very smart regulations and initiatives over the last 30 years, an internal consumption, so very high consumption of its own prefabricated wooden buildings. So Swedish wood buildings stay in Sweden. Austria is second, but still a relatively small market share compared to conventional construction. And you can see some of them, not surprising, Northern European countries high in both exports and internal. And just again, in terms of value, prefabricated wood buildings in the European Union, maybe my map's a little light, but imagine Europe behind those green dots. Sweden, Germany, as I mentioned, also the UK, quite large. As we move to the continent, there's very little wood-based construction, even in some countries that have fairly large forestry sectors. But the good news is there has been significant growth in terms of value from 2003 to 2018. Also prefabricated metal buildings. It's by value, it's a much higher value part of the building products of the European Union. And the big blue dot you see, but you may not see the country behind it because my maps are a little light, is Italy. But the prefabricated metal building sector is a little different in that prefabricated metal building in Europe is still focused primarily on exports and on reusable buildings. The wood sector is actually more focused on permanent construction, which is not to say that metal buildings can't be permanent, but these systems are primarily focused on relocatable buildings. I also use the ready-mix concrete, again, using the same data source. Ready-mix concrete is a good indicator of the degree of conventionality to the construction industry in Europe. So we see it fairly, whereas the other two maps, the relationship between the overall value of the construction industry population and the metal and wood buildings are not aligned. The ready-mix concrete pretty much matches in many countries the relative size or the relative economy. What's interesting though is ready-mix concrete has been in terms of value has been pretty much the same more or less over the last 15 years, as opposed to the growth we're seeing in those other two sectors. So that's a kind of trying to understand, developing kind of one of the things we're doing at MOD X too is trying to develop tools for assessing where a market is, how mature, and which countries and which regions are ready to take the next step in this endeavor. So I'm going to talk now a little bit about the actual modular process, and I'll focus on the US simply because it's something we know well, but I'll also show some of the comparisons to Sweden, where modular construction is also quite mature. Just so we understand a little bit about it, this is a photograph of a typical modular manufacturer in the United States. There's probably about 200 of them. Typical factory size in square meters is about 10,000 square meters, so not huge. Fairly low automation and fairly organized assembly lines, really using some mechanized elements and some just conventional construction, but in a controlled environment. So there's usually a kind of panelization process in the factory, and then very large modules are moved along really day by day. It's a fairly slow process, faster than conventional construction, not particularly automated yet, where different enhancements are completed. These drawings are probably a little too small, but the key, we can see an early step where walls, panels, ceilings are constructed using light wood frame elements, and then gradually enhanced. Construction works from the inside out as opposed to the outside in, and modules are usually 50 to 60% complete, with some work still being done on site. This is just a little bit of a zoom in. This is really just a taste. And here's the assembly of a modular home. Actually, this is after one of the hurricanes and about 5 years ago, Sandy, and you can see there's insulation, windows installed, and some of the electrical work has been completed and will be connected. Often, due to a number of factors, the final facade is applied on site, but much of the work can be completed. This home is completed in a day. Another interesting thing about this is with the unfortunate increase in weather events in the United States and in other countries, modular construction, due to the rigidity that modules need for transportation, the forces that they deal with the day they are set are the worst forces they will ever deal with, even in an earthquake zone. It's one of the reasons that also it's an additional benefit to volumetric modular in the US at least, which is the durability, both in earthquake zones as well as in hurricane zones. So just looking at looking at the set of a very typical, really shows almost a generic project. This is a 4-story apartment building, actually in Boston. So again, as you can imagine, the setting of a crane is very important. In fact, crane locations are part of the design process. There is usually a foundation and often a conventionally built commercial floor. And then really modules in the United States are quite large. So 20-meter lengths, 25-meter lengths sometimes, and widths of 4 or 5 meters being placed. And in this project, and in most projects, the design in a successful project, and this is something I'll talk about a little bit more in the conclusion, really, unlike in conventional construction where we prepare a drawing set, and then we make some decisions about how we are going to construct it in offsite industrialized modular construction, those considerations need to be made very early on. And so you can just see some of the steps in the process. This is a New York, this is a mid-rise 12-story residential tower in New York City, steel system. I'm just going to click through this, sort of the assembly of that project. So as this industry matures, we're starting to see a lot more clear research. So Robert Hairston, who's a colleague of ours in Scotland, has developed a simple tool for measuring the degrees of prefabrication and enhancement of systems. So levels of prefabrication, 1D, 2D, and 3D elements before they leave a factory, and levels of enhancement, structural elements, insulation, even cladding, and mechanical, electrical, plumbing. So in the United States, the industry has grown from the manufactured housing industry into the modular industry. And the process goes from first prefabricating from 1D elements to 2D elements to 3D elements, and then enhancing those three-dimensional objects, almost like a small building in a factory. In Europe and in Japan, there's a different approach, and it has to do with the history, not the technology, but the history of those industries, the recent history of them, in that most of those industries began as panelized industries and then shifted into three-dimensional elements. So so I'm just going to go to the next, the process of enhancement. So for going from a panel to an enhanced panel happens first, and then those panels are assembled into volumes. Why is that important? Well, in the US, the tolerances, the quality of lumber, but also the manufacturing process creates problems with precision in the site. And for example, in places like Sweden, and actually probably only in Sweden, the quality of lumber is so high that it really improves both the manufacturing process as well as the tolerances. It allows for wood construction to achieve tolerances that in some ways are comparable to steel. And so really, in Sweden, volumetric modules, three-dimensional modules, are actually made up of highly finished panels. Why is that important? Because those panels are able to be really manufactured in a fairly automated process to a high degree of precision and control before they're assembled. And those connections are quite high, which also means that the degree of prefabrication and enhancement that can happen in a factory are significantly higher because the tolerances are significantly higher. This process, and this is Helena Lidlow, who's a colleague of ours and the head engineer of Lindbäcks BIG, which is a really leading company in Sweden. This kind of manufacturing process is also supported by a very sophisticated manufacturing culture, which understands the fabrication process as a kind of data-rich environment, one that is exposed to continual improvement and feedback loops, and that this data culture is actually the foundation and the prerequisite for digitization and mechanization. So companies like Lindbäcks have their own project management tools, but those project management tools have grown out of the company culture. Helena is the head engineer of Lindbäcks in Sweden. Is also an academic, a colleague of ours, and she's developed this very useful chart that explains the relationships between kind of conventional construction and manufacturing on a continuum. And I've tried to clarify the Hurt charts further. So on the top, we have we can understand as typical projects that we all know, at least in architecture, where codes and standards define the parameters, and there's a detailed design process, which involves a number of parties. Decisions are punted often towards the late into the construction and deep into construction. At the bottom of this, if we go down, is really a product-based approach. So most economy cars, but also manufactured homes in the US. Some of these reusable homes we've seen used also in Europe, where really a product is manufactured and a consumer or a client is given the choice of variants. In the middle, though, is this interesting space, this really the space that we think is ripe for more innovation and more architectural thinking than is currently happening. It's a space of what's known as the product platform. So a kind of system that manages between manufacturing inputs and, let's say, client inputs. And this is where more open systems, so prefabricated structural components, but also more closed modular systems, so systems that have predetermined parts that can be configured fall. So this really means very much designing a system and then engaging with that system. And so really the product platform is a system that manages the inputs of a client or a client and an architect between manufacturers and assemblers. And so this is a kind of new design problem. Product platforms are defined as collections of modules of parts that are common to a number of products. This commonality is developed intentionally to achieve desired effects in order to create value. And I've just explained it in maybe simpler terms. A product platform can be understood as a game with finite but flexible sets of playing pieces, like Legos, or better yet, like dominoes. And if we have time, I can even get into some more theory at the end, we'll see. So modular construction then, again, just the definition I introduced earlier, is not just the use of three-dimensional prefabricated components, which is the way it's often defined, but it's a game. Hopefully it's a game where we have a clear set of pieces that have been pre-designed for play. So construction set using a set of subassemblies that have been specifically designed and manufactured for use in a predetermined manner. So we need to know what we're going to be doing with these components. So I just this is interesting because a company like Lindbach's, I showed you some of the images of their production, has a fully functioning product platform for multifamily up to 8-story structures in Sweden. And this is just an example of their recently published architecture manual, which really works like a very clear set of instructions and parameters for clients and architects to work with their system so these are just parameters that explain how their modules work. What are the on the left, what are openings between modules that are possible, what kind of shear walls they use. On the right, typical wall sections. And again, this is not mass timber construction. This is lightwood frame construction, which is significantly more economical at this point than mass timber construction. Mass timber is great, but it's not quite economical under certain stories. And again, this is all in Swedish, but just to see the level of thought and parameters that they provide architects. And this is a cross section of one of their structures. One of the things you also see in this structure is a challenge of modular construction, which is the doubling up of structure by having modules that are rigid. But that also creates some advantages in light systems, like lightwood systems, for example, acoustical separation or increased structural rigidity. And what's also interesting, I'm actually wrapping up here, is that as an architect, what I've noticed in this process, just like what I've noticed in our iPhones and our other products, is a product platform, when used correctly, is an open system in the sense that while each fabrication is designed for a specific particular use, as the product platform is designed by certain people and used by others, it learns. It has a kind of evolution, and there's a kind of intelligence that grows out of that. And so buildings like the one I showed, which in this slide, which is a project underway by Lindbach's, or a recently completed project like this, also in Sweden, are actually learning from this feedback loop in ways that conventional construction doesn't. And I just actually wanted, this is just maybe a provocation for discussion, is that in Poland, for example, so some of the examples I focused on are housing, but another industry that's really become very enamored with this kind of construction is hospitality. And since we are speaking in a Croatian context, this is not a mock-up, but is a actually complete component for a hotel being produced in Poland by DMD Modular for a site in New York City. So the hospitality industry, which is also a big part of the Croatian economy, is companies like Marriott, franchises like Marriott, Citizen M, which is a European brand, have really committed to this form of construction, and certainly they have their challenges currently with COVID, but this is certainly going to be something we're going to see more in this space as well. But in the interest of time, I'm actually going to stop here, and so I might come back to some more theoretical slides, but I'd love to have a bit of discussion. Thank you very much.
Yeah, thank you, Ivan. It was so nice and to hear from you and to listen about this, I think, really important topics, because you also said, why now? This is very interesting. Why now, 2021, why is it important? I think you showed us, amazing research. That's you're dealing with this, I think, over 10 years since I know Bogdan Budimirov and some things that you're researching about New Zagreb and the development. And maybe while we're making some questions, because we already have some, but I'll try to start just a little bit, because you mentioned creation context, tourism, and so on. We had a fantastic legacy, actually. We have a fantastic legacy here. All four of your topics, industrial construction, even prefab, and it was really developed since the Second World War in socialist Yugoslavia, from the 50s to the 70s, 80s. And I mean, because I know that you know about everything about that, and maybe the question, or not question, that's thing for discussion. What can we do now? Because you're also familiar about state of our industry, about industry of those industrial prefab and everything, things that can be developed here. And you know the possibilities. I'm just not going to mention wood as a resource from Croatian wood. So, what is your opinion about that? About developing? Because we all know that this is kind of collapse of almost everything from the point of transition from socialism to capitalism in the 90s. The things that's happening now. Nothing changed in these 30 years, basically, almost nothing. Yeah. So, what's your opinion about the state of not state of nation, but state of industry?
Yeah, well, I think I have to say first, I'm very thankful to have known Bogdan Budimirov and a lot of what I know about the industry. And it's funny because his knowledge was based on some knowledge from the 20s, 30s, 40s, and 50s. It's still relevant today, but unfortunately isn't taught. It's not taught along with some of the construction principles. Really, the success of a company like Jugomont was not in the factory. It was actually in the drawing board. It was in using the same kind of planning tools that industry uses. It actually wasn't that mechanized. It was fairly mechanized. It was appropriately mechanized, but it really was in tools. For example, being able to economize the use of a very expensive material like aluminum was only possible through a manufacturing mindset in terms of design, as opposed to a manufacturing mindset in terms of let's put machines in factories. And that's something that is not, we've had a hard time explaining that to students because architecture also is enamored with replacing all of our problems with technology, getting rid of them through technology. And actually, whether that's some of what I alluded to in Lindbach's is that they really built a kind of data culture that Bogdan would have been very familiar with. Would have been like a no-brainer for him. And it was using the same principles that would be a no-brainer for an Apple employee, or really even someone in retail. And we don't even have that language in construction. We in some cases, some firms in high-rise construction, because it's kind of important, you can't screw it up. But in most construction, we're okay with it because the quality and the cost, we just eat and eat and eat. And that's what the McKinsey report is sort of showed too, is that we've been punting the cost for so long, but when you look at it as an industry, it's disturbing, and it explains why there's just a lack of understanding. But specifically, I mean, I think in Croatia there's a couple of things, right? I mean, I think one, also Bogdan's last act before he gave up and said, "I'm going to Germany," like many people, was to set up a factory with Spačva in the east of Croatia, because there was. One, because there was resources, but two, because there was know-how, and three, because actually the market wasn't even for Yugoslavia, it was for Germany. It was really through Koja magazine, which is like a mail order magazine, it still exists. And what killed that process wasn't, the end of socialism, because by the way, that project died in the late 60s, but it was really a lack of competition in Yugoslavia and a focus on purchasing patents as opposed to developing IP. That's also, and that's actually, there's a really great, so Matko Meštrović had an interview in the late 60s with Bogdan, who was already living in Germany and was a consultant for German companies, because he had real world experience on these large scale projects, and explained very clearly. And those, again, the principles there is no principles to reinvent. We just don't apply them to construction. There's nothing new here. It's really, the technology is new, and there's some great new technologies. Another factor is that we are close to, Austria, in Croatia, it's close to Austria, northern Italy, Switzerland, which is, interesting enough, it's a hotbed of innovation. It's having a hard time expanding. The conventional construction is still not, or mass housing is still not adopted some of the most innovative approaches. So CLT was invented in Austria. Most construction in Austria is not even close to what it is in Sweden or even in the UK. So some of those cultural barriers are not clear. And I think certainly in a place like Croatia, as we can see from our colleague Mario Furcic, it's hard to imagine wood construction, even though it's quite common and quite economical in other places. And then there's obviously the tourism point, which I just raised, which is tourism and hospitality. Really, if it wasn't for COVID, and I'm sure it's going to come back, the rate of adoption of these approaches in hospitality is really going through the roof, particularly in places like the United States, but also in Northern Europe. So, there's a lot of things. There are a lot of things that are going on. But I think like with our research on the peripheral moment, assuming that there are not continuities, but there are opportunities, let's say.
Yeah, definitely. From the resources on. But yeah, maybe the care of this industrial construction, more, or let's say, in the prefab and everything else, is a kind of a new, because we have, for example, in wooden industry, we had companies, for example, Historia, which is dealing with the furniture, but they start actually from nothing here. But okay, we have some questions. I don't know if we have an answer for Mario Furcic about I have a feeling.
I do, yeah. I mean, I think it's interesting that, so the two countries, so in the United States, builds with wood, not because they care about signaling virtue, they care about cost, right? And it's funny because the way that people build in Croatia was brought from the US by Portland Cement Company in the 20s and 30s. And it wasn't because it was cheaper, it's because the US is really good at selling fear to other countries, because fire and termites, which is true, but also was if you look at the advertising and the way people talk about wood construction, it's very aligned, and it's fear mongering more than anything else. But the reason that people build in the US out of wood is because it's cheap, and it's not always the best quality, but I've lived in a wood building in Boston that's 115 years old, and it's fine. But also places like Sweden. Sweden imported light wood frame construction, particularly from the US in the 90s, and also improved on it because it was the cheapest form of construction, not because it was sustainable. It could be sustainable if it's done right. And Japan imported it in the 1970s. So really, actually, after the energy crisis, a lot of countries just stopped subsidizing concrete. The concrete lobby and concrete was expensive to transport. In fact, even the Soviet Union stopped doing precast to the same scale because of the energy crisis, even though they weren't directly affected by those kind of market forces. So wood has a commercial advantage to countries that have forestry sectors. If you want to introduce it in a country without value-added forestry sector without building up that forestry sector, it would be more expensive than certainly any conventional construction. So no, I think it's a good, but I also think it's constructing again tomorrow out of wood without having that supply chain and that built up, I think it would also be kind of crazy. But I think there will be a lot more interest and again, regional cooperation around finding ways to create rural jobs, to engage with CO2 emissions, and you'll see a lot of public funding going in that direction, and that will make. And as you pointed out, I think you were just saying there are specialized, very high quality specialized companies producing components in Croatia based on the forestry products that would certainly be a great seed for.
Yeah, that's always amazing. That from around Zagreb, there are companies who are producing for BMW, for really the biggest companies, but components. Okay, let's quick question about Kaya asked about the name of the Swedish book. Can you repeat?
So Lindbacks Big, BYGGE, but that's just a construction company in Swedish. Lindbacks, like it.
Yeah, and our mutual friend Thea Jakula, I have two questions. Thank you for a very interesting presentation. I have two questions. One, currently modular buildings are predominantly wood buildings. Since there are certain benefits of having building with higher thermal capacitance, e.g. concrete, is there a possibility to have modular building in the future that are built for some more massive, higher thermal capacitance material?
Well, first of all, wood has. I mean, there's now research, scientific research that's underway in countries that have a longer tradition of wood construction that's looking at thermal capacity of particularly mass timber. So mass timber, which is the darling of public discourse, is currently expensive for certain kinds of construction, more so than. So in the U.S., there is not a lot of mass timber construction. There is some. Most of it is light wood frame construction. So I mean, concrete, steel is. There's a lot of steel modular in the U.S. and Europe and the U.S. And you can see in Europe there's probably more, at least by value, than there is wood. I think concrete has had there are some interesting hybrid systems. There's a German modular system, which is not very large scale, but it's pretty innovative, called Lee Wood, Lee Wood, which is a hybrid precast concrete and CLT modular system. But I think one of the issues has been just the general cost of concrete when it's not subsidized, but also the cost of transport of concrete, and then obviously the CO2 impact. So it's interesting to see. And there's passive house, and there's good examples of passive house being achieved through very light construction, particularly because of manufacturing principles are applied to it. One of the largest federal programs right now in the U.S. is really looking at how to achieve passive house standards more economically through any kind of factory construction, simply because of the control. So, but there's also obviously there's a lot of research in the concrete industry in general and lowering the emissions impact of concrete. So that there's a lot, but it's interesting. There hasn't been, other than in the U.S. and in Europe, other than facade panels, which continue to be precast reinforced concrete, there haven't been a lot of systems. In Saudi Arabia, there's a very large initiative. The Saudis are developing kind of almost a 60s scale national program.
Not in Russia, in the 60s and 70s.
Yeah, but they're three-dimensional low-rise, and they brought in a U.S. company.
Yeah, that was also the case in New Zagreb and New Belgrade in Yugoslavia. Okay, another question from there. I'm reading from the face because it's not here. In your opinion, how will the artificial intelligence change the industry?
Well, I think artificial intelligence is changing a lot of technologies. I think without a manufacturing culture and construction, no technology will impact it, and it hasn't. So that change, which we've known what we needed to do for about 100 years, and we haven't done it. And so I think there's a barrier. There's a cultural barrier in construction, without which, which explains the McKinsey report, which again is really worth looking at. It gives some things we've all experienced as architects, as engineers, as contractors. Just gives it a context that I've never had. I wish I had done that report. I didn't have that data. Didn't have that money to do it. But it really shows the kind of just the business as usual approach of construction, really not working. And so I think the first step and the way to unlock all kinds of other innovations, technological innovations, new software, new hardware, new machinery is really a fundamental change in project management and project delivery, the role of the professions. And without that, it's going to be very hard to gain benefits.
Yeah. We're going to talk about it with some other in the next lectures month with some other people who also tackle this thing. Samantha Pavic from Split, great lecture. Thank you, Ivan and Sasha. Given the current situation in Petrinja and other locations across Croatia that were affected by the recent earthquake, what would be the preliminary steps in order to implement successfully MOD X system?
Yeah. Well, I think at MOD X, one of the things we've been showing, even in more mature markets, is unfortunately we think of the ultimate results of site construction can be speed, and it often is. But to build up an industry takes more time than it does to build a building, even a conventional building. It really takes some time, and we haven't seen a way to get around it. So I think for something like Petrinja, where there's an immediate need, and for something emergency. Yeah. So we've seen. I mean, it's interesting. The floods in Zagreb used offsite construction as a result, but actually the industry was declining. So we have in the U.S. the FEMA, which is the Federal Emergency Management Association, which was actually built for nuclear war, but now works around natural disasters. They are the biggest consumer of some of the, let's say, lower end of the spectrum of offsite construction in the sense of very low cost, and they help keep certain manufacturers in business because they give them pre-orders. So they say, you'll be licensed by us if you have a certain amount of backlog, or are you able to produce. And so when you have a mature industry, it helps. I think the bigger motivators that have helped these industries is to understand that the offsite industry produces high quality jobs where people have benefits and salaries in a way that construction has not, and does a better job in Europe than in the US. Those kind of societal benefits have been a little bit. Also, it's interesting. Manufacturing jobs are, in terms of gender, are much more diverse, so you walk into a factory in Sweden and it reflects the population in a way that construction sites don't. And so those kind of things, from a societal lens, have a much bigger impact. And I think the goal is, I think in Croatia, the shortage of labor is probably a bigger impact. It's going to have a bigger impact than the very real need that kind of response to. So if we had a industrialized industry, it would be easier to respond to other kinds of natural disasters, but it's very difficult to develop it with the kind of needs that kind of post-earthquake. Well, but actually, in Sweden, though, one of the things that's come out, which would be very interesting for the longer-term reconstruction of Zagreb, is that one of the big advantages of CLT, or mass timber construction, is that it's, because of the lightness of the structure, it's actually kind of has almost a magical property that you can add, 3 to 4 stories to certain kinds of structures without really having to do significant reinforcement. So I stayed in a hotel in the north of Sweden that was a kind of 2-story reinforced concrete bay, and they were able to add 4 stories of structure without making a significant impact. So that's something that's also very interesting in terms of a different way of understanding how we renovate buildings.
Okay. We don't have any questions, but I know that you're busy, that you have another thing to go. Actually, we had live 330 people, which is not bad.
Oh, great. Excellent.
And we talk about making another maybe talk or something during, I would say, next month, but maybe with some other participants. I think that would be very nice to deepen all the questions and things. And I think it would be very nice to do that. Do you have anything more to say? Or I think you already said everything.
Well, visit the MOD X network. We've been doing. We have a lot of content. If you're interested in this topic, both free resources as well as kind of short 20-30 minute discussions on different topics, including AI. including the cost of wood, including emergency response.
It would be nice to make another one with maybe wider audience or some people involved in the next conversation. Yeah, okay. Thank you, Ivan. Hope to see you very soon. Thank you, everybody, for watching. Follow urania.hr and all other events that we are trying to keep alive. Of course, with online things like that, and I think we will have a kind of 2-week, appearances and some lectures. We will try to to do that every two weeks. Okay, Marco. Never mind. Okay, thank you, Ivan, again. Thank you, everybody. You can all watch this lecture, I think, on our link, as for anybody who didn't participate now. And yeah, that's it.
Voila.
See you. Bye.